Okay, ideally, I'd like to just maybe discuss some stuff for 15, 20 minutes and then have the second half of class be some work time for you to do some problems on your own. So Aaron, you said you ran into confusion?
Yeah, because I got lost when there's no why.
Okay. So
Me too.
So that's number 2.
I guess I gave them all yesterday. So, yeah, what was the function?
F of x is equal to
X to the 4 plus
You
6x.
plug it into
When x equals -2.
Yeah, so remember our goal ultimately is to utilize point slope form. And so you go, well, how do I get the point? The point is going to come from this equation. So this is going to give us the point. And then this is going to give us the slope. Okay, so to use point slope form, yeah, you got to get the point. The point comes from the actual function. And then the slope comes from the derivative function. So let's plug this number in here. So f of -2 would be -2 to the 4th plus 6 times -2. So that's 16 minus 12 is 4. Okay, so what that means is if you were to graph this function, now I know it's 4th degree. I mean, we know that it contains the point 0, 0, and then I think some negative number, -6, but who knows what it looks like? I really don't know. But the idea is we know that at -2, it's got to have a y value of 4. So this point is 2, 4. And now the question is, well, what's the tangent line? Okay, what's the tangent line? So you plug -2 in here. So you plug -2 in. So that's going to be -8 times 4, -32, the -26. So as you can see, I guess my drawing was like somewhat accurate because it's a really steep line. It's really, really, really steep if the derivative is -26. If you saw that if you graphed this and your graph was on a 1-to-1 scale, it would look like a practically vertical line. That's how steep it is. So anyway, my equation's got to be y minus 4. Where's the 4 come from? It's my y value of my point equals -26 plus 2. So here it's x minus. Oh, sorry, I had a little typo here, my bad. -2. Does everyone agree with that? Are there no disagreements, no questions?
I will say that anytime you're writing on the whiteboard, it's very satisfying. It's just like very nice. And
Thank you. That's a very nice compliment.
Yeah.
Thank you. Thank you, George. Okay, so do you guys feel okay on just any question that's like, what's the tangent line equation or? Oh, thanks. Sorry, I almost forgot to say it. It's the printer's fault, Trey. See, if I had it in front of me, I should just print out a new one. I just feel bad, Jesse. You affected my mind. Now if I print some paper, I feel guilt. So try to avoid it. Anyway.
Well, now we can't even recycle anymore. So.
What?
Didn't we get rid of our paper recycling?
Well, we're kind of conservation. We're just kind of collecting it and just having
Distributing it.
Yeah, we're just taking it to the
Recycle place.
yes. So technically, we don't really have a recycling system. It's mostly just like whenever we can, people just load piles of paper into somebody's car and then they take it to
Effective system.
Okay.
Very effective.
The word normal is, so the question might ask you, what's the normal line? Normal is just a fancy word for perpendicular. Okay? Those are just the same thing, pretty much. Okay? at least for our purposes here. If you hear the word normal, trust me, it's not me trying to be like, oh, it's a perpendicular line. That's what everyone calls it. Like, oh, well, there's the tangent line, there's the normal line. So a line can be tangent to the function or it can be normal to the function. So like on this one, the normal line would be, the normal line is perpendicular to the tangent line. They make a 90-degree angle. So quick little review of that. With slopes, suppose for a moment, I'll make a little chart here of slopes. Let's say that your let's say your tangent line slope was 2/5. What would be your normal? Very good. Your normal line slope would be -5/2. So the word for that is opposite reciprocal. I guess it's 2 words. So opposite meaning if one of the numbers is positive, the other one's negative, or if one of the numbers is negative, the other one's positive. Reciprocal means it's quote unquote flipped over. So let's say the tangent slope was 3. Well, the reciprocal is 1/3. You got to make it opposite, so it'd be -1/3. Or let's say your tangent slope was like -1/7. Your normal line would be +7. So hopefully that chart is. If you want a rigorous definition of what opposite reciprocal means, it's 2 numbers that when you multiply them together, what do you get? -1. So you could say something like. If A and B are opposite reciprocals, then A times B is -1. It's kind of unnecessarily precise definition, but if you wanted one there, I know you were clamoring to know that.
Yes.
So say you're doing a process. So out here, this is a good example one. Let's say I wanted to know the normal line for this one. Well, can I use the same point? Yeah, so I would just go y - 4 equals +1/26 times x + 2. This right here would be my normal.
What happens if the slope is 0?
Oh, good question.
Straight line. Oh, vertical line. Okay.
That's very impressive, Gail.
That was impressive. Wow.
That was a nice.
The bar is low. The bar is low.
So then you just do the.
Is this number 4?
Yeah.
Okay. So yeah, let's look at number 4.
Okay.
Number 4 is a bit of a trick question. So you get all these, these procedures, and then you get hit with say a horizontal line.
Well, bam.
What's perpendicular to a horizontal line?
The
Vertical line. And how do you write the equation of a vertical line? It's just going to be x equals something. So we might as well go through the problem just so we have another example to work from. It's thank you. So here, g of x.
So this one.
So it's asking for the normal line. What's the normal line to this parabola when x is 3? Well, some quick calculus gives us a derivative of 10x minus 30. And then wait a second, when I plug that 3 in, I find that the derivative is 0. So what did I just find, by the way? By the way, I should get probably maybe, I don't really need this, but if I plug in 3, g of 3 would be what? 45 minus 90 plus 7, so negative 38. It's way down here. But the point being, don't quote me on where this parabola is crossing the x-axis. I know you guys were going to. So this point here at 3, is that what you got, Jesse? Negative 38 for your y value?
Mm-hmm.
Well, the tangent line
It's just y equals negative 38.
would be y equals negative 38. The normal line
It's
be x equals 3.
Okay.
Okay. So, any questions on that?
So the normal line is actually equals 3.
Yeah, let's back up a sec. So do you understand why the tangent line has 0 slope?
Yes.
Okay. And do you agree that if you have 0 slope, then your horizontal line, and then do you agree that if your tangent line is horizontal, then your normal line would have to be vertical?
Perpendicular, yeah.
And then the last step is you'd have to agree that to describe a vertical line, this is how you do it. Because remember, guys, line equate, like, head back to the early days. If I show you this function, that's a rule. That's a rule that says every point that lives on this structure, which we call a line, every point has an x and a y value, right? Well, the rule, in order to live on this line, to get into the line, there's like a bouncer or something, your y value has to be 3 bigger than double your x value. If not, you can't live on this line. If your y value is 4 bigger than double your x value, then you'd be above the line. Okay, you're not on the line. So how do you describe a vertical line? Well, like say this, if you're on this vertical line, well, every point here has this, they only have one thing in common. They all have the same x value. So to describe that line there, you would just go x equals 3. Everyone okay with that?
Mm-hmm.
Yeah.
So for one, that the slope isn't 0, like 3, the equation is y minus 2 equals negative 2 x minus 1.
I got 1/2 x minus 1.
Well, that would be for the normal. So it would be just a half to make it the normal.
Yeah.
Oh, yes.
Yeah, so on 3, you should get your slope is negative 2, which means your normal line would have an opposite reciprocal of positive 1/2.
And then you put that in the equation as a final answer. Like that y minus 2 equals a half form.
Yeah, use point slope form again, so your equation was 2 over x, right?
Yeah.
Okay, so I don't know, draw a little sketch of that. And they were talking about the x value of 1, right?
Yes.
So 1, 2. So your point is 1, 2. And so if you took your derivative, you had negative 2 over x squared, which at 1 would give you negative 2. So that agrees with my picture here. My tangent line has a slope of negative 2. And so your normal line use the same exact point, but you make the slope opposite reciprocal. So you would just go y minus 2 equals positive 1/2 times x. Make sense?
Yeah.
Okay, so I want to just do maybe one more example of an estimation. There's got to be one in there where I asked you what's the square root of 26, or like square root of 17 or something. Maybe number 20? Was it 26 or 17 or 15? 26. Okay, so here, this is going to be another example of a tangent line approximation. And then this hopefully will be the last thing I go over, and then you guys can take the rest of the class to work on your assignment. So the question is very simply stated. It's what is approximately the square root of 26? This is the question. Now, for years, we've known the answer to this. I mean, what would you say if you ask this question to like a little kid? They're going to say roughly 5, a little bit bigger than 5, right? Well, okay, so the question, if I wanted to be really precise, the question would be, what is the best linear approximation you can get to this using a simple integer input? That'd be the wordy way of saying it. So what do you think is what's the closest simple integer input into the square root function? 25. So what we're going to do is this. We're going to say, consider this. This is the square root function. So this is y equals square root of x. Okay. Way over here at 25. Okay. There's a tangent line. Now, do you all see how in the neighborhood of 25, like if I go over to 26, that my tangent line is awfully, awfully close to my function? They're very close to each other in that neighborhood. If I go too far off to the right, it's not going to be a very good approximation. If I go too far to the left, it's not a very good approximation. But in this neighborhood, it's pretty good. So what I'm going to do is say, well, what's the equation of this line? What is my tangent line equation? Well, I need two things to construct that equation, right? What are the two things? The slope and the point. Okay. Okay, so wait, are you wearing AirPods? Could you please take them out? Please. Even still,
interrupted you this whole time.
I appreciate you not interrupting me. If you could not wear headphones, I appreciate it. Okay, so this point here is 25.5 is the point. There's my point. To get the slope, I gotta take the derivative. So I gotta go y prime. What's the derivative of this function? 1 over 2 root x. If that's what you don't know by heart, you can go x to the 1/2 turns into 1/2 x to the negative 1/2, just using your basic power rule. But hopefully this is one you kind of got embedded in the old brain there, deep in the wrinkles. So what's the slope at 25 then? Yeah, 1 over 2 is 1/10. So what that means is my tangent line equation would be y minus 5 equals 1/10 times x minus 25. Does everyone feel good about that? Understand? No? Okay, so what's the final step to this? We're going to plug in 26 into this.
26 or root 26?
26, because, so here, let me rewrite this. Okay. So what this says, this is making a claim. It's not an obvious claim at all. What this is saying is that near or in the neighborhood of 25, I can say that the square root of x function is approximately equal to this function. This marker sucks so much. It's so squeaky. Hopefully you guys can read that on here. Does that make sense, this claim here? Okay, so now what you would say then is, well, if this is true, if we can see that it's true based on the picture, the tangent line is very, very close to the curve, then I can say that the square root of 26 can be approximated by 1/10 times 26 minus 25 plus 5. And here's where you get kind of an underwhelming answer.
Yes, it is.
Because 1/10 of 1 is 0.1. So you're kind of like, okay, well, that's kind of what our common sense told us at the beginning, right? But what you'd say is that this is the best first order approximation you can get, first order meaning like using the first derivative. If you're interested, you can actually take this and you can write it as not in terms of the first derivative, you can actually use second derivative, third derivative, fourth derivatives to actually get a really approximate polynomial. It's called a Taylor expansion or a Taylor approximation. But anyway, and that's a huge thing in mathematics, is taking weird functions like e to the x or sine of x or something and writing it as a polynomial approximation. But anyway, there you go. So 5.1 is the best approximation you can get for that.
But who is Taylor? What is that?
Taylor is just some dude. I can't remember his first name. Let me look it up for
You're
you.
talking like a tailor as in a profession.
Oh, no. It's
I feel like I've heard that.
I do talk pretty funny.
It's named after a guy named Brooke Taylor, who was a mathematician in the early 1700s. So he's after Newton. So Newton had the idea. He invented calculus, and I'll show you a famous example. I might have to Google it real quick to make sure I'm not giving you the wrong answer. But so if I look up the e to the x Taylor series, it's a really famous one. You get so it's a really famous one. So we all know this function, right? E to the x. You can show this is more like Calc 2, but you can show that e to the x.
There's 4 of them.
Yeah, there's
What?
many.
Usually it goes Calc 1. Calc 2 involves more advanced applications of the same stuff we're talking about, but also it'll often expand into like some two-dimensional stuff and some like polar coordinates. And then Calc 3 would be a lot of like three-dimensional stuff, like doing calculus or on vectors.
That's so exciting.
But what happens at the 4th level?
You typically don't have a Calc 4. Some universities might offer a Calc 4, but usually the classical progression goes Calc 1, Calc 2, Calc 3. And you take a class called differential equations. So differential equations would be like, I give you a formula like the second derivative of some function plus double the first derivative of that function plus the function equals 0. What kind of function has that property? And you have to figure out what kind of, that's called a differential equation. We will study very simple differential equations in this class. Like something, I'll show you a really simple one. Really simple, ready? Y prime equals, say 2x. And you'd say, oh, I know a function whose derivative is equal to 2x. X squared plus some constant. And I just solved the differential equation. So
What about Calc 69?
wow, epic me. Anyway, so that's all I was saying. So this function, it turns out, you can write it as x to the 0 over 0 factorial plus x to the 1 over 1 factorial plus x to the 2 over 2 factorial plus x to the 3 over 3 factorial. And the more terms you do, the better the approximation is to that. And then technically, if you take the limit, if you go to infinity, if you take infinitely many terms, it actually is truly equal to e to the x.
Punctuation point. What's
What?
the punctuation for it?
This?
No, exclamation point. That you
Oh,
have.
factorial. So like, so like 5 factorial is 5 times 4 times 3 times 2 times 1.
Ah, I thought you said 5 really excitedly.
No. It's a factorial. So
0 over 0.
anyway, guys, so go ahead and work on your assignment. And if you're stuck on something, if you have questions, let me know. I can try to help you.